New observations and measurements bring 3I Atlas back to the center of scientific attention, not due to rumors or speculation, but because of a concrete sequence of results that demand urgent re-evaluation of everything we thought we knew about this interstellar visitor. The most recent post-perihelion images reveal a compact nucleus without the expected massive tail, while precision astrometric measurements indicate lateral displacement and non-gravitational acceleration that continues to challenge our understanding of cometary physics. But there's something more disturbing happening behind the scenes. Sudden administrative changes in space agencies, public reports about strategic dismissals, and growing speculation about political motivations to withhold or release high-resolution images could change everything. On the 4th of November 2025, President Donald Trump made an announcement that caught the scientific community by surprise. On his Truth Social network, Trump announced the replacement of Sean Duffy as NASA administrator with billionaire Jared Isaacman. The timing didn't go unnoticed. Many people began commenting that this replacement happened right after a controversial response on Twitter directed at Kim Kardashian, a coincidence that raised eyebrows throughout the astronomical community. Was this merely a routine administrative change? Or is there something deeper at play when it comes to 3I Atlas observations? While everyone awaits the end of the American government shutdown and the release of the best 3I Atlas images captured by the HiRISE camera, something extraordinary happened. China's National Space Administration broke the silence. China released images obtained on the 3rd of October 2025 by the Tianwen-1 Mars orbiter at a distance of 28.96 million kilometers from 3I Atlas. These aren't amateur images. They're professional-quality scientific data from one of the world's most advanced space missions. The Tianwen-1 orbiter, which entered Mars orbit in February 2021, used its high-resolution imaging camera, HiRIC, equipped with a 38.7 cm diameter primary mirror, although it has lower resolution than the 50 cm aperture of the American HiRISE camera. The Chinese images are revolutionary. The released HiRIC images show 3I Atlas's nucleus and a surrounding coma with a diameter of several thousand kilometers. Even more impressive, Chinese researchers generated a complete animation of 3I Atlas's trajectory in the Martian sky based on a series of 30-second images that capture the object's movement in real time. In a surprising turn, an American congresswoman decided to break official silence. On her social network, she published a statement confirming what many suspected. Just had a good conversation with NASA about 3I Atlas. As soon as the government reopens, they will release images and data. Unfortunately, for bureaucratic reasons, this cannot happen until then. Dr. Avi Loeb from Harvard was correct in his initial analysis of the anomalous tail. NASA also observed this. I'm sure this will be one of many interstellar objects we'll be able to track now that technology has advanced. This statement is explosive for several reasons. First, it officially confirms that NASA observed the same anomalies that Avi Loeb identified. Second, it suggests there are many more anomalous interstellar objects than the public knows. And third, it admits that crucial data is being withheld for bureaucratic reasons. The numbers don't lie. Models based on the most recent observations using the same parameters that reference teams routinely use point to two crucial alterations in 3I Atlas's trajectory. One, inexplicable lateral displacement. The object showed significant variations in lateral position, left-right, relative to previous predictions. Curiously, there was no appreciable vertical displacement, suggesting a highly specific and controlled movement pattern. 2. Persistent non-gravitational acceleration. The acceleration signal continues to be present, but with magnitude revised to approximately 1/3 of the initial value published after perihelion. Even reduced, the acceleration maintains statistical significance and remains classified as unexplained by conventional gravitational forces. Technically, this means there are additional acceleration components in the orbital plane parameters known as A1 and A2, while the perpendicular component A3 remains compatible with 0. In practical terms, forces act laterally and radially without lifting the object out of the plane in which it moves. The 5 billion-ton paradox Here's where physics becomes impossible to ignore. The standard interpretation of non-gravitational acceleration in comets is simple. Mass ejection creates a rocket effect that modifies the trajectory. Applying conservation of momentum to measured values and assuming typical ejection velocities for cometary gases on the order of hundreds of meters per second, physical estimates indicate that 3I Atlas should have lost a significant fraction of its mass, something on the order of more than 13% during the time of close passage near perihelion. This scale implies the release of billions of tons of dust and gas material that would tend to form a vast coma and tail detectable even by modest observatories. The problem is that post-perihelion images don't exhibit this massive cloud. Instead, the nucleus appears compact and the coma is modest. Reducing the estimated acceleration relieves quantitative pressure, less mass loss required, but doesn't qualitatively resolve the fundamental fact there's non-gravitational acceleration and no cloud-matching classical calculations, impossible chemical composition, preliminary spectroscopy, and comparative analyses reveal traces that defy explanation. Nickel predominance with almost complete absence of iron, carbon monoxide to water ratio extremely elevated, signatures compatible with rare volatile compounds, possible byproducts of industrial processing, such as nickel tetracarbonyl. These readings are surprising for a body originating from cold and primitive regions of space, regions that tend to produce objects rich in ice and with typical rocky composition. Optical polarization measurements indicate extreme negative polarization values, interpreted as signals of large, highly porous and structurally complex particles completely different from what's observed in typical comets from our system. The three remaining hypotheses, with current elements, only 3 hypotheses remain scientifically viable. 1. A typical natural comet. Expanded models that contemplate directional ejection, particles that don't form an extensive coma, or ejection at much higher velocities, adjustments that would preserve a natural origin, albeit exceptional. 2. Non-thermal mechanisms or internal engines. Impulse sources that would expel mass at much higher velocities than expected for thermal degassing, drastically reducing the need for large-scale mass loss. 3. Artificial probe or artifact. Requires extraordinary demonstrations, artificial emissions, geometric structure, uncontroversial industrial compositions. Although improbable a priori, the hypothesis cannot be discarded until specific observational tests refute it. The 10 definitive 3I Atlas anomalies. 1. Retrograde trajectory nearly aligned with the ecliptic. 3I Atlas entered the solar system following a retrograde orbit, but surprisingly aligned within a few degrees of the planetary orbital plane. Interstellar objects usually arrive from random directions. This alignment is statistically almost impossible. 2. Anti-tail jet directed at the Sun. Images captured the formation of an anti-tail, a beam of dust and gas pointing directly at the Sun. This behavior is opposite to what's established by traditional cometary physics, where solar radiation pushes material back. 3. Atypical mass and velocity. Estimates indicate that 3I Atlas's nucleus possesses dimensions above the average for comets combined with high displacement velocity. This association is extremely rare and may indicate material more resistant than common ice and dust. 4. Synchronized sequence of planetary approaches. 3I Atlas performed a series of coordinated close approaches to major planets, making direct observation from Earth difficult. This orbital dance deliberately reduced the window for collecting the most sensitive data. 5. Atypical chemical composition. Spectra revealed unusual nickel predominance, almost complete absence of iron, and high ratio of carbon monoxide to water. This composition suggests origin in astrophysical environments completely different from known ones. 6. Extreme negative optical polarization. Measurements indicated negative values more intense than usual for cometary dust, pointing to larger, highly porous particles with complex internal structure, not common in comets of local origin. 7. Origin direction near the WOW signal. 1977. Trajectory projections indicate approximate origin from the same celestial region as the famous WOW. Radio signal detected in 1977. The directional coincidence reignited debates about a specific cosmic route. 8. Anomalous photometric evolution. 3I Atlas showed sudden brightness increases with strong green emission visibly altering its coloration. This brightness didn't follow the traditional thermal activity curve, appearing in unexpected peaks. 9. Acceleration mass loss paradox. Models attribute acceleration to gaseous material ejection. However, subsequent images didn't show the amount of debris that would justify such impulse, creating a fundamental physical paradox.